Hi, my name is Stefan Fela from Image Meadows LLC. This section is going to present the results of a portrayal thread in the testbed 13. Today, the sharing of layers and portrayal information is difficult because we have to deal with different data sources, data models, and implementation. Each portrayal system are basically built in silos. The goal of the testbed 13 was to investigate ways to enable semantic interoperability, sharing layers, maps, and portrayal information, such as symbols, portrayal rules, and styles, that are independent of a data source and data models using standard REST API. There were three outcomes for this testbed effort. The first one was the creation of a set of portrayal ontologies, which provide a semantic knowledge representation of portrayal information that can be understood and reasoned by machine. The second one was the implementation of a new REST-based services called Semantic Portrayal Service, which manage layers and portrayal information, but also perform rendering of layers, symbols, and legend. The third one is the implementation of a web client for the portrayal service that demonstrates the capabilities of a service. The main benefit of this work is that it enables the sharing and linking of layers and portrayal information on the web, but also enables the semantic mediation of symbologies. The following video will show you some of the results of this activity.
The home page provides an overview of the latest layers and portrayal information. From here, we can navigate to the respective search pages, create new layers and portrayal items, or view additional details for a layer. Let's navigate to the search page for portrayal items by clicking on the View button. Each search result gives us a short overview of the portrayal item and a legend graphic if applicable. The search page allows us to search for items by free text, sort results by relevance, title, or created date, or facet results by item type. We have several different types of items in the system, mostly symbolizers, but we can additionally support styles, style sets, feature type styles, rules, rule lists, symbols, and symbol sets. For example, we can facet by polygon symbolizer to narrow our search results to only polygon symbolizers. Let's now look at the details page for a polygon symbolizer. Here, we can view more details about the item in question. For symbolizers, depending on the type, the details can include the stroke, fill, shape, or source URL. A preview of how this symbolizer will look when applied to a layer appears on the left. From this page, the user can also view the item represented in various encodings and can export the item in this encoding. If there is a symbolizer that we would like to have that is not encoded in a file, we can create it through the user interface. From here, we can select the type of symbolizer and then modify the appropriate attributes. Let's create a point symbolizer. From here, we can modify the size of the stroke as well as the color of the stroke and the fill. We can also select a predefined shape and control the overall rendered size. Once we are happy with our symbolizer, we will give it a title and then save. Now, let's take a look at layers. Currently, we have some layers from the mass migration scenario WFS and also some layers that describe country and state boundaries that came from GeoJSON sources. You may notice that there are duplicate results of some of the country boundaries. This is just for demo purposes, to demonstrate the tool's capabilities. One layer is described by a remote GeoJSON source that is accessed through a URL, and the other layer is described by inline GeoJSON. On this layer search page, we can facet by data source type or keyword, just like on the portrayal item search page. But here, we can also search by spatial area of interest by selecting a geographic extent on the overview map. Let's look at the details of a layer that was imported from a WFS. On this page, we can view the rendered layer, which is served up by our internal WMS. We can also view metadata about this layer, including the URL at which the original WFS source is located. We can also programmatically apply one or more symbolizers to this layer and render the result. Let's apply a polygon and line symbolizer from the agricultural surface style SLD file. We can also change the order that the symbolizers are applied. Right now, the line symbolizer is rendered underneath the polygon symbolizer, so the bright yellow outline is not its true 3-pixel width. If we change the order, the line symbolizer is brought to the front, so we now see the full width of the stroke. If we are happy with the applied symbolizers, We can clone this layer as is for reuse. To create new layers, we can provide the URL of a data source that has been encoded in CSV, GeoJSON, GML, shapefile, or a WFS. For this first example, we will look at data served up in GeoJSON. So we will provide the URL, select GeoJSON as the data source type, and click on the Render button. This will trigger the server to request data from that URL, and then render it to the left. Similarly, we can retrieve data from a URL providing shapefiles. This zip containing shapefiles describes the locations of airports around the world. We can also apply a symbolizer to this data. For example, let's apply the aviation point symbolizer by typing aviation in the search box. Now that the layer data has been retrieved, and we have applied a symbolizer, we can save this as a new layer.